Welcome to Weather with Enthusiasm. This is your daily morning briefing produced by Call Sincha Productions, and today we are diving deep into some truly wild stuff.
We really are. It's going to be an intense one today.
Yeah, so whether you are starting your day in West Rogers Park in Chicago or, out east in Baltimore, Lakewood, Borough Park in Brooklyn, or even down in St. Louis, we are so glad you're here.
Absolutely. And, the goal of this deep dive is to basically decode the sky for you.
Right, because right now, millions of people are checking their phones to see if they need an umbrella today. But at the exact same moment, religious scholars are using these, incredibly complex atmospheric algorithms to determine their morning prayer schedules.
Which is just a fascinating intersection of ancient wisdom and modern physics. We think our digital calendars rule our lives, but we are really just entirely at the mercy of the atmosphere.
We totally are. So we are going to start our daily structure by looking at the Zmanim, which are the halachic times for observant Jewish communities. And I'll be walking us through the exact times for today, June 8th, 2026.
And for those who might be newer to this, Zmanim aren't just fixed times on a clock. They breathe with the seasons, right?
Exactly. They change every single day based on your exact geographic coordinates and the sun's position. So starting with West Rogers Park in Chicago, zip code 60645, dawn, or Elos Hashachar, is at 3:23 a.m. today.
And that is early, but astronomically speaking, that isn't when you see the sun. That is just when the sun hits exactly 16.1 degrees below the eastern horizon.
Right, the light is just sort of scattering off the upper atmosphere.
Yeah.
So it's 3:23 a.m. for Chicago. Then we have Mishiacher, the time you can recognize an acquaintance, at 4:10 a.m. And sunrise, or nets, is at 5:15 a.m.
And that sunrise calculation is actually factoring in atmospheric refraction. The air literally bends the light over the curvature of the Earth.
Which is just mind-blowing. I mean, you're seeing a mirage of the sun before it's physically there. So that's nets at 5:15 a.m. for Chicago. Now, because the days are so long right now in June, our proportional hours are stretched out to over 76 minutes.
Right, which pushes all the morning deadlines way back.
Yeah, so for West Rogers Park today, the latest time for the morning Shema using the Gra calculation is 9:02 a.m. Halachic midday, chatzos, is 12:51 p.m. Sunset, or shkia, is 8:26 p.m. And nightfall, tzais, is at 9:16 p.m.
And if we look east, that schedule shifts completely because of the geography.
Right, so let's move to Baltimore, Maryland, zip code 21215.
Right.
Because they are further south and east, their dawn is at 3:56 a.m. Sunrise is at 5:39 a.m.
So they have a bit of a later start than Chicago.
Exactly. Their latest Shema is at 9:22 a.m. Chatzos is at 1:04 p.m., sunset is 8:30 p.m., and tzais is 9:15 p.m. for Baltimore.
It is amazing how just a few degrees of latitude completely redraws the day.
It really is.
Yeah.
Okay, moving up to Lakewood, New Jersey, dawn is 3:45 a.m., sunrise is 9:1 p.m.
And it'll be just a tiny bit different for Brooklyn, right?
Just by a few minutes, yeah. For Borough Park in Brooklyn, dawn is 3:4 a.m., sunrise is 5:1 a.m., the latest Shema is 9:1 a.m., chatzos is 12:53 p.m., sunset is 8:22 p.m., and tzais is 9:09 p.m.
Which really highlights why you can't just use one calendar for the whole East Coast.
Exactly. You really have to know your exact location. And finally, swinging back to the Midwest for our listeners in St. Louis, Missouri, dawn is 4:08 a.m., sunrise is 5:36 a.m.
Quite a bit further south there.
Yeah, so their daylight is a bit different. Latest Shema for St. Louis is 9:10 a.m., chatzos is 1:03 p.m., sunset is 8:24 p.m., and tzais is 9:06 p.m.
That is a phenomenal breakdown. And of course, as our halachic experts always advise, you want to add a 2-minute buffer to these times.
Right, because local weather and barometric pressure can actually bend the light just a tiny bit, more or less on any given day.
Exactly. The sun sets the ultimate boundaries, but the atmosphere beneath it dictates what we actually experience. And that brings us to the weather forecast for today.
And you are handling our plain English forecasts as the National Weather Service deep dives today, Ryan.
I am. Let's start with a plain English look at what's happening. For Chicago, especially around West Rogers Park, we are looking at a very soggy, very active Monday.
I noticed it looked pretty gloomy out there.
It is. Temperatures will top out near 80 degrees, but we have a persistent northeast lake breeze today. So if you're near the lakefront, it will feel noticeably cooler than if you go further inland.
Okay, good to know.
The main story, though, is heavy torrential rain. We are expecting multiple rounds of thunderstorms throughout the day, and the primary threat isn't wind or hail, it's flash flooding.
Wow, really? So we're talking viaducts filling up, that kind of thing?
Exactly. Pounding rain over the exact same neighborhoods over and over. Now, for Baltimore, it's a bit different. You'll see temperatures in the mid-70s, but it's going to feel very damp and raw. There's a coastal system pushing moisture onshore, so expect scattered showers and just generally unstable, gloomy conditions along the I-95 corridor.
Sounds like a good day to stay inside. What about Lakewood and Brooklyn?
Very similar setup to Baltimore. Lakewood and Borough Park will be locked in the low to mid-70s with mostly cloudy skies. There's a persistent onshore wind off the Atlantic, so periods of rain and drizzle are likely throughout the afternoon. It won't be a washout every single hour, but you definitely want a raincoat.
Got it. And what about St. Louis?
St. Louis is actually going to be the hot spot today. Highs will push into the upper 80s, feeling very humid. They have a threat for some isolated, pop-up severe thunderstorms later this afternoon as a small disturbance moves overhead. So keep an eye on the sky down by the arch.
So basically everyone needs an umbrella today, just for slightly different reasons.
Pretty much, yeah. But to really understand why it's doing this, we need to dive into the National Weather Service Area Forecast discussion, the AFD. And we promised we wouldn't skip or summarize the technical jargon. We were going to say the terms and then decode them.
I am so ready for this. When I read the Chicago NWS report today, it looked like a foreign language. They started off by warning of a hydro concern.
Right. So hydro concern is forecast or shorthand for hydrological issues. Basically, they are telling emergency managers to stop worrying about tornadoes today and start worrying about water pooling on roads, overflowing creeks, that sort of thing.
Okay, that makes sense. But then they immediately drop this massive physics term. They say the storms are firing along a, quote, theta-e gradient along a surface stationary front.
Ah, yes. Theta-e. It sounds incredibly intimidating. It's spelled theta-e. It stands for equivalent potential temperature.
Okay, what does that actually mean for the people in West Rogers Park trying to go to work?
Well, normally we just look at the regular temperature, right? Like it's 80 degrees outside. But theta-e measures the total energy of an air mass by combining the physical heat and the moisture content.
Oh, because humidity holds energy.
Exactly. It's called latent heat. When water vapor turns into liquid rain, it actually releases hidden heat into the atmosphere. So an air mass that is 80 degrees and incredibly humid has a much, much higher theta value than air that is 80 degrees and bone dry.
So it's basically a metric of how much thunderstorm fuel is in the air.
Perfectly said. And the NWS notes a theta gradient. A gradient is just a sharp dividing line. So imagine a wall separating very low energy air from that super high energy sticky air.
And they called it a stationary front, which means that wall isn't moving right.
Exactly. It's just stalled right over northern Illinois. So this hot, sticky air rams into this invisible wall, gets forced straight up into the sky, and explodes into thunderstorms. And because the wall isn't moving, the thunderstorms just keep forming over the exact same spot.
Which explains the hydro concern. The storms are just acting like a conveyor belt dumping water on Chicago.
You got it. Now, the next term the NWS highlights is steep lapse rates.
Lapse rates, I've heard that before, but I always forget how it works.
It's actually a pretty simple concept. The lapse rate is simply the speed at which the air gets colder as you go higher up in the sky. Usually, if you climb a mountain, it gets colder, right?
Right, the higher you go, the cooler the air.
But how fast it gets colder is everything to a meteorologist. If the lapse rate is steep, it means the temperature drops off a cliff as you go up. The air miles above us is freezing cold.
Oh, I see. So if that hot, sticky air from the surface gets forced up, it's going to act like a hot air balloon.
That is the perfect analogy. The hotter the air inside the balloon is compared to the freezing air around it, the faster and more violently the balloon shoots upward. Steep lapse rates mean the updrafts in these thunderstorms are going to be explosive.
That's a great visual. Now, here's an acronym that was all over the discussion. P-WAT. P-W-A-T. What is a P-WAT?
It stands for precipitable water. I want you to imagine the atmosphere over your house is a giant invisible sponge.
Okay, I'm picturing a giant sponge over Chicago.
P-WAT measures exactly how much liquid water you would get if you squeezed every single drop of moisture out of that giant atmospheric sponge, from the ground all the way to space.
Wait, how do they even measure that? How do they know what's miles above us?
They use weather balloons called radiosondes. They launch them twice a day across the country. The balloons fly up to about 100,000 feet, beaming back humidity data the whole way.
Oh, wow, that's actually really cool. So they take that data and calculate the P-WAT.
Yes. And today, the NWS says the POT values over Chicago are exceptionally high. That giant sponge is completely saturated, which is why they warned that these storms could produce, quote, instantaneous rain rates over 2 inches per hour.
2 inches an hour. That's just an absolute deluge. That's how a street floods in literally 10 minutes.
It is. Now, the forecasters wrap up their severe weather assessment by looking at 3 more critical terms: CAPE, shear, and vorticity.
I feel like I always hear about CAPE during tornado season.
You do. CAPE stands for convective available potential energy. If theta is the total energy of the air mass, CAPE is the actual usable explosive fuel for a specific thunderstorm. Think of it like the size of a car's engine. Huge CAPE means a massive engine.
Okay, so we have a massive engine today. What's shear?
Shear is the change in wind speed or direction as you go higher up. If CAPE is the engine, shear is the transmission. A thunderstorm needs shear to tilt it over slightly. If there's no shear, the rain just falls straight back down on the storm and chokes the updraft, killing the storm.
Oh, it suffocates itself.
Right. And today, the NWS says the shear is actually quite weak, so the transmission is bad. But they say there is ample vorticity.
Vorticity? It sounds like a vacuum cleaner or something.
It sounds like vortex, right?
Yeah.
It's simply the amount of ambient spin or rotation in the atmosphere. Even with weak shear, if there's enough ambient spin, these explosive updrafts can grab that spin and stretch it vertically.
So because of the huge KP and the ample vorticity, they said they couldn't totally rule out a funnel cloud today, even without great shear.
Exactly. But the more likely threat they mentioned is a wet microburst.
Yeah, let's talk about that, because the physics of a microburst sound completely terrifying. What happens in a microburst?
When a storm dumps a massive amount of rain, like we have today with that high P-WAT, it drags air down with it. As that rain falls into slightly drier air, some of it evaporates. And evaporation is a cooling process.
Like when you step out of the shower and feel cold?
Precisely. So the air inside the storm's downdraft gets incredibly cold. And cold air is much denser and heavier than warm air. So you get this massive, incredibly heavy pocket of cold air plummeting toward the ground at highway speeds.
And when it hits the ground?
It explodes outward in straight lines, like dropping a water balloon on a concrete sidewalk. The winds can easily exceed 100 miles per hour, snapping trees and taking off roofs.
And the damage looks like a small tornado, but it's not rotating. It's just straight line wind.
Exactly. So that is the incredibly complex engine hovering over Chicago right now. But let's briefly touch on the NWS highlights for the East Coast and St. Louis.
Right, because our listeners out east are dealing with a totally different setup.
Yeah, so for Mount Holly and the Baltimore, Washington NWS offices, they focus on a coastal low and onshore flow. That just means there is a low-pressure system spinning right off the coast, and the winds are blowing from the ocean onto the land.
Which brings all that damp Atlantic moisture right over Lakewood, Borough Park, and Baltimore.
Precisely. The NWS notes that this is pooling moist, unstable air right along the I-95 corridor. And finally, for the St. Louis NWS office, their main buzzword today is a shortwave trough.
A shortwave trough. What is that, like a ripple in the atmosphere?
That's exactly what it is. A trough is just a dip in the jet stream, and a shortwave is a fast-moving, smaller ripple inside that dip. When that ripple passes overhead, it forces air upward, which is why St. Louis has that isolated thunderstorm risk today.
It's honestly amazing how forecasters can see all this invisible structure in the sky, and they publish this incredibly dense area forecast discussion, not really for us, but for emergency managers and pilots, right?
Yes, exactly. It's the scientific reasoning behind the little rain icon on your phone app.
Right. Well, understanding all this highly technical jargon really isn't just an academic exercise, because if we fail to accurately predict and communicate what the sky is doing, it has catastrophic consequences. And history reminds us of that on this exact date.
It really does. Today's date is a somber one in meteorology.
It is. Looking at the history sources for today, we're going back to June 8th, 1953. On this day, an F5 tornado struck the northern suburbs of Flint, Michigan, specifically a community called Beecher.
And just for context, an F5 is the absolute highest rating on the Fujita scale. Total devastation.
Complete devastation. The historical archives describe this storm as an absolute monster. It was half a mile wide. The winds were estimated at over 260 miles per hour. It killed 116 people and injured 844.
It remains one of the deadliest single tornadoes in American history.
It really is just staggering. And it was part of this larger system called the Flint-Worcester outbreak. Because the very next day, the exact same weather system produced a massive F4 tornado in Worcester, Massachusetts.
Which is incredibly rare for New England.
Right. And across the whole outbreak, 251 people died. Just makes you wonder, why were the death tolls so incredibly high? I mean, I know F5s are unsurvivable above ground, but did they have any warning?
They essentially had none. And scientifically and historically, this tragedy is what changed everything. Because up until the early 1950s, the United States Weather Bureau had literally banned its forecasters from using the word tornado in public broadcasts.
Wait. They legally couldn't say the word tornado on the radio? What was the logic there?
It sounds insane to us today, but it was rooted in the technological limits of the time and, frankly, a bit of government paternalism. First off, they didn't have a weather radar network yet.
So they were just relying on balloons and surface barometers.
Basically, they could tell when the atmosphere had high theta-e and shear, to use the terms we just learned, but they couldn't tell where a storm would actually fire. So they thought, if we issue a tornado warning for the entire state of Michigan, we are going to cause mass panic.
They thought the panic would kill more people than the storms.
Exactly. They literally believed people would run out into the streets, crash their cars, and trample each other. So they chose silence over a false alarm.
Wow. But the massive loss of life in Flint and Worcester completely broke that policy, didn't it?
It shattered it. The public outrage was immense. You had modern, industrialized communities getting wiped off the map with zero warning. It exposed the severe inadequacies of the government's approach, and it directly spurred the development of everything we rely on today.
So the government had to pivot. They lifted the ban on the word tornado.
They did. And more importantly, they poured money into the first nationwide weather radar network, the WSR-57. They transitioned from repurposed military radars to dedicated weather systems.
But even with radar, back in the 50s, they couldn't actually see the wind rotating, right? They could only see the heavy rain.
Right. Doppler radar didn't come until much later. So to solve that, the Weather Bureau realized they needed human eyes on the ground. This tragedy birthed the nationwide spotter network.
Oh, like the Skywarn program.
Exactly. They started training regular citizens to look at the clouds, identify wall clouds and funnel clouds, and call it into the forecast office. It was a complete paradigm shift from hiding information from the public to enlisting the public as partners in detection.
The contrast is just amazing. I mean, earlier we were talking about NWS offices calculating ambient vorticity down to the decimal point in real time. But in 1953, they were literally flying blind.
We've come so far in detection, our lead time for a tornado is now around 13 minutes on average.
But even with supercomputers and push notifications on our phones, we still struggle with how humans react to warnings.
We do. That's the great modern challenge. We solved the meteorology problem, but we haven't solved the psychology problem. Getting someone to wake up, grab their kids, and run to the basement when an alarm goes off is incredibly hard because of warning fatigue.
Right, because we hear sirens for storms that just produce heavy rain, so we just assume it's a false alarm and we look out the window instead of taking cover.
Exactly. But bringing this all back to today, we have the immense privilege of having highly detailed forecasts. We know we have a stationary front dropping torrential rain on Chicago. So how do we practically apply this knowledge so we don't get caught in a flooded viaduct or a wet microburst?
Yeah, we have a great list of curated indoor family activities for Chicago today for exactly this reason. You've got the rundown on those, right?
I do. If you're looking to safely get the kids out of the house in Chicago today, we have some phenomenal indoor options. First on the list is the Peggy Notebear Nature Museum up in Lincoln Park.
Oh, that's a classic.
It really is. And the absolute highlight there for a gloomy day is the Judy Eyestock Butterfly Haven. It's this 2,700 square foot tropical greenhouse with over 40 species of free-flying butterflies. It's constantly kept at around 80 degrees with perfect humidity.
So you step in there and completely forget the stationary front outside. It's a total climate escape.
Exactly. And they also have the Look-In Lab where kids can see live reptiles and amphibians, but they also feature an interactive exhibit called Riverworks.
Which is incredibly ironic considering the NWS is warning us about flash flooding and hydro concerns, and we are telling people to go to an indoor water play exhibit.
It is a bit ironic, but honestly, there is a profound pedagogical value to it. Think about it. Safe, simulated natural environments like water tables and aquariums are incredible tools. They teach kids to understand and respect fluid dynamics and natural forces without being traumatized by the actual severe weather happening in the real world.
That's actually a brilliant way to frame it. You're teaching them the physics of the water while staying perfectly safe from it.
Exactly. Now, speaking of aquariums, the Shed Aquarium down on the museum campus is another great option today. I highly suggest their 11:00 a.m. Best of Shed guided tour. It's a 75-minute behind-the-scenes access tour.
Oh, that sounds amazing. Kids love seeing behind the glass.
They do. Now, if you are looking for something a bit more historical, the Frank Lloyd Wright Home and Studio in Oak Park has indoor architectural history tours running until 3:45 p.m. today. It keeps you completely out of the rain.
And if you have younger kids who just have endless energy to burn, the Field Museum is perfect.
Oh, yes. They have an ongoing Pokemon exhibition that runs all the way through April 2027. You could easily spend 4 hours walking the halls of the Field Museum while the sky dumps rain outside.
And what if that theta gradient actually nudges north and the storms break later this afternoon? Is there anything outdoors?
Yes. If the radar clears up, the Edgewater Monday Market is happening from 3:00 to 7:00 p.m. It's located at the Broadway Armory parking lot at 5917 North Broadway. It's very walkable from West Rogers Park if the atmosphere finally gives you a window.
That is a great list. So you don't have to be totally paralyzed by the weather. You just have to adapt your schedule to it.
Exactly. Make informed decisions based on the science.
Well, as we wrap up this deep dive today, let's cast our eyes toward tomorrow. Because the celestial clock never stops ticking and the atmosphere just keeps churning. So let's look at tomorrow's Zmanim for our 5 communities.
And we'll see a slight shift as we continue marching toward the summer solstice.
Right, so for tomorrow, Tuesday, June 9th, in Chicago's West Rogers Park, dawn moves a minute earlier to 3:22 a.m. Sunrise moves to 5:13 a.m. The latest Shema is 9:02 a.m.
And for Baltimore?
For Baltimore, tomorrow's dawn is 3:56 a.m., sunrise is 5:39 a.m., and latest Shema is 9:22 a.m.
Very consistent there.
Yeah, and for Lakewood, New Jersey, dawn tomorrow is 3:44 a.m., sunrise is 5:29 a.m., and latest Shema is 9:3 a.m.
And Brooklyn?
Borough Park, Brooklyn, dawn is 3:39 a.m., sunrise is 5:26 a.m., and latest Shema is 9:19 a.m.
So daylight continues to expand, and as for tomorrow's weather outlook, the NWS says we will see gradual improvement across the Midwest.
So the stationary front finally moves.
Yes. A weak ridge of high pressure will build in, which brings sinking, stable air. That will choke off the thunderstorms for most of our communities. But of course, the atmosphere always balances the scales.
Oh no, what's the catch?
The catch is the heat. Once the rain clears, intense heat builds in by Wednesday, with heat indices projected in the mid to upper 90s. All that fresh rain will just evaporate and create oppressive humidity. And by Thursday, a new upper-level low moving over Manitoba could bring a serious squall line threat.
Wow, so the cycle of calm and violence just begins all over again.
It's a relentless machine.
It really is. And I think that leads perfectly into our final thought for today's briefing. You know, we live in this incredible age of digital calendars, smartphones, climate control offices. We can order food to our door without ever stepping outside.
We really live in these bubbles.
We do, and it gives us this profound, almost arrogant illusion that we have totally mastered our environment. We feel like we are the undisputed bosses of our own daily timelines.
But the reality is completely different.
Exactly. The truth is, the precise mathematical angle of the sun slipping below the horizon and these invisible, chaotic gradients of moisture hovering thousands of feet above our heads, they're the ones still pulling the strings.
Whether it's atmospheric refraction dictating the exact minute you can say your morning prayers, or a stalled boundary of latent heat forcing you into a museum, the sky is ultimately in charge.
We are, and always will be, creatures of the sky. So keep looking up and stay curious. Thank you so much for joining us on Weather with Enthusiasm.
Yes, a huge thank you to all our supporters who make this daily briefing possible.
And to our listeners in West Rogers Park, Baltimore, Lakewood, Brooklyn, and St. Louis, please make sure to subscribe and share this with your community. We will see you tomorrow for another deep dive into the sky.